We present Dance Like a Chicken, a low-rank adaptation method to stylize human motion generation. Given a text prompt, like a person is jumping, we employ low-rank adaptation to stylize it. The same action and semantics can be generated with a chicken style, with legs apart, or even with both together. Contemporary motion generation models excel in understanding the span of human actions, which offers great text-to-motion generation capabilities and semantic editing. But when asked to generate stylized motion, such as jumping like a monkey or like Superman, contemporary models struggle, no matter how the style is described. We argue the root cause is in the data. Most typical datasets depict actions with very little style, and datasets dedicated to style are limited to basic locomotion actions. This leaves the combination of actions and style out of domain. To overcome this gap, current works use editing techniques such as classifier guidance and control net, or attention feature injection. These approaches still struggle with combining actions and styles. Our key observation is that pulling a specific generation toward a style ends up out of domain, failing to capture at least one of the action-style axes. Instead, our LoRA-MDM approach shifts the motion manifold as a whole, preserving its structure. This way, all actions are augmented with the style and their content is not lost or forgotten. We start from a motion prior trained on the traditional actions dataset and expand it with low-rank adaptations for all the attention layers in the model. The idea is that low-rank adaptations perform low-frequency changes that shift the learned manifold without losing its structure. We train this LoRA to shift the motion manifold using a small set of reference motions, and meanwhile keep applying the original training loss on the actions examples to preserve the manifold structure. With as few as 7 examples, LoRA-MDM generates intricate motions that are still faithful to the style. This includes, for example, jumping or fighting. Note that a model chose capoeira moves for fighting, which better fits this style. We compare our method to textually describing the style in the prompt, a method based on classifier guidance and control net, and one performing attention feature injection. As can be seen, the alternatives produce either the correct action or correct style, but are unable to combine both. How about a Superman style? Again, as can be seen, describing the style in prompt fails. Momo reproduces the style but has no dancing frames to draw attention features from, and Smoothie's guidance pulled the generation out of its domain. On the other hand, LoRA-MDM naturally combines the dancing with the style. We also demonstrate LoRA-MDM integrates naturally with other control tools in the diffusion ecosystem. Here we showcase control that involves a prompt, a style, and input trajectory. Note how motion nuances nicely emerge during generation, especially in the right arm and knee of the bottom animation that helps the character turn rightwards. We also show style mixing. The same LoRA model learns 2 styles with 2 different tokens, which allows using them both in the same sentence. Quantitatively, LoRA-MDM demonstrates a great trade-off between motion quality, prompt alignment, and adherence to styles. For more details, please refer to the paper. Thank you. See you next style.